we're back again. I'm talking about basic programming ideas for artists. So it might not make any sense to you, but if it does, keep watching because we're going to go somewhere. We looked last time at what variables are. These are things that can change, things that can vary. And in C++, we use strongly typed variables. i.e. we have to say, this is a number, this is a name, this is a decimal number, and we have integers, floating point numbers, booleans for true or false, strings for names, which is great, but often we'll have multiple things. Say I've got 10 people coming to my barbecue, I might want to keep all of the names. Now, I could make a string called names and then say names equals Jane, Mahir, Evan, etc. And I would, because it's a string, because they're words, I would put them inside quotes, and I could separate each one with a comma. Not greatly helpful because I have to go through and say, well, no, Jane has 4 letters in her name, but Mahir has 5, Evan has 4, Stephen has a different number, Tom has a different number, etc. What I could do is make a list of all the names, and all the items in the list would be strings. And lists, one of the ways that we can make a list in C++ is to make a vector. Helpfully, vectors are directions for when you're committing crimes with direction and magnitude, or in this instance, they're lists of things. You might have heard of the term arrays, and arrays are sort of going out of fashion because, I don't know, they listen to the wrong music now, but essentially everything's done by vectors. Vectors are slightly more flexible than arrays, if you've heard of arrays, in that a vector can get bigger and smaller. It's a list of things, and we can put any kinds of things in there. So if I wanted to make a vector, I could have a vector of strings, and each string would be a name of somebody coming to the party. And every time somebody replies to me, I can just put their name into this list or vector of all the names coming. What's cool is I can count how many things are in that vector. So I could say, rather than making a great big string that I have to keep searching for, I'm just going to make a string called name, and I'm going to make a vector, and I need to say what kind of type of stuff is in this list. Think of it as like a ladder or a whole load of boxes glued together. So these actually turned up with a load of cables, but I could stack my variable one on top of the other, and another, and another, and another, and another. And each one is containing one variable in a big stack, and that's my vector. That's how I think about it, like a ladder or a sort of shelving that just gets bigger or smaller as I need it to, and each shelf has got an individual thing on it. So in my vector, I have to specify what type of thing is going to be in there. And in this instance, I want to put a vector of strings, and I'm going to call this vector names. And when I make names, it's actually going to be a list that can only contain this type of variable, strings. I could make a vector of integers, I could make a variable of floats, so I could put all the times that people arrive or their dates of birth. So we can make this list or vector called names that contains strings. In each string we're going to put name of an attendee, and we're going to stack them all together so we get an object. I think of it as a ladder, a set of shelves, a stack of all these variables side by side. And to add a name is when we make our initial vector called names that can contain strings. It's empty, there's nothing in it. But I'm going to say we have a new name. So I'm going to make a string called new name. And then I'm going to say the new name I want to put in my list And again, we're doing camel case or lowercase n at the beginning and then a capital N in the middle. New name equals, because it's a string, I use quotes. Jeff. And then I want to put this new name variable into my vector of names, into my big list of names. So I can say names is my vector, dot, and the dot means this is something that this object can do. And I can use the expression pushback. Get a variable and put it into my vector. Get another one and stick it on the back of it. Get another one and stick it on the back of it. Get another one and stick it on the back of it. I wish I had more boxes of these. They're in the other studio because I've got a nice stack of about half a dozen. But I end up with this stack of variables of whatever type. In this instance, it's strings all stacked together in a list, in a vector. So I'd say push back whatever is in my variable new name. So now we've actually got a complicated looking piece of code here. I say take the vector that we named up here called names. It's going to be full of strings, and stick something on the end of it. And this is going to be the first piece, but it could be the nth piece. Push onto the back of it this variable in new name called new name, and it's Jeff. And I can do this again and again and again. I can say now the new name is Jane. Push back new name onto names, and now names has got one bigger and one bigger and one bigger and one bigger. What's cool is this list, this vector with strings in, or they could be integers or floats or anything else, I can go and look up what's inside it at any point. So I could say, if I want to find out what is at name number 2, I could say, what is at names, and then in square brackets, position 2. So I could go to position 2 in this list and ask it to print it out. I could ask it to say, if the name at position 2 is Jane, then do something. So I can make now integer variables, float variables, string variables, Boolean variables on or off, and now I can make vectors. So I can put all of these things in lists inside vectors, which means I can start making these reusable things again, like being able to say, find out how many people are coming to the barbecue, find out how much my glass, my fork, my spoon, my plate weighs, multiply them together, and just tell me, do I need a truck or a bicycle? And I can do that same calculation again for the next barbecue, whether there's 10 people or 100 people, where I could come back and say, actually the weight of the glass changed. Do a different kind of glass that's heavier. And all I do is update the weight of the glass in its variable, and the calculation still works. So we make these structures that we can reuse and reuse and reuse, and run them multiple times, rather than having it just as one fixed calculation. And now we're starting to program, we're starting to do structures. And if we can start to think about that, I want this thing to happen, how can I break it down into little bits that if it were my proverbial idiot cousin, what would I have to tell them? So, that is vectors. We designate a vector, we say what's going to be inside the vectors, and we give it a name, and then we can use things like pushback to add things into the vector, and we can use our square brackets to find out what's at a particular point in the vector. We can also do additional things like find out how big the vector is, what size it is. We can delete things from it, and we can add and subtract and sort it, all kinds of really useful things. Next time we're going to be looking at counting and making loops. If this makes any sense to you, please do put some comments below. Tell me about the things that are making sense, what you want me to talk more about. Like and subscribe, and hopefully I'll see you on the next video.